Good day, everyone. Welcome to our short review questions on Newton's laws of motion, work, power, and energy. I have prepared here multiple choice type of questions that focus on the core concepts of Newton's laws, work, power, and energy. Let's start with which of the following is Newton's first law of motion? Okay, now the correct answer is letter C. So C is the right answer. An object at rest stays at rest, and an object in motion stays in motion, unless acted upon by an external force. So letter C is the first law of motion, also known as the law of inertia. And inertia, by definition, is defined as the resistance of an object to change its state in motion. If the object is at rest, that means a bigger mass would mean greater resistance to change its state of motion. The smaller mass means lesser resistance to change its state of motion. Now let's proceed to number 2. Which of the following is an example of Newton's third law of motion? Okay, and the correct answer is letter C. I hope you get it right. Letter C is the one that talks about Newton's third law of motion, also known as the law of interaction. For every action, there is an equal but opposite reaction. So as a rocket launches, it is launching forward due to the gas that was expelled from it backward. And letter A is talking about is more on the application of the Newton's second law of motion. Letter B, a book remains on a table unless it's pushed, is an example of the first law of motion. So with letter D. So our answer here is letter C. Next, if an object of mass 5 kilograms is accelerating at 3 meters per second squared, what is the force applied to it? Here in this item, we are asked to determine the force. We are given the mass, which is 5 kilograms, and the acceleration, 3 meters per second squared. So given the mass and acceleration, then how can we determine the force? And the answer is second law of motion. Force, since the force is equals to mass times acceleration, and the mass is equal to 5 kilograms, while the acceleration is 3 meters per second squared, multiplying 5 by 3, you get 15, and the unit is Newton, since kilogram meter per second squared is equal to Newton. Next number. If the net force of an object is 0, then what can you conclude about its motion? Okay, so this particular question is an application of Newton's first law of motion. And the answer here is letter C. It must have constant velocity. If the net force of an object is 0, there are two possible scenarios in its motion. One, the object is at rest, or second is It is moving in a straight path at constant velocity. That's why our answer is C. It can never be A because when the object is accelerating, that means the net force is not zero. Likewise, when it's slowing down or when it decelerates, the object's net force is non-zero. So C is the right answer. Number 5. A 10 Newton force is applied to move a 2 kilogram object for 4 meters. What is the work done on the object? In this item, we are asked to determine or quantify the value of work. So, the scientific perspective of work is that it is equal to the product of force and displacement. So it talks about the application of force that causes the object to move or displace. And the answer here is, since we are given with a force of 10 Newton, a mass of 2 kilograms, and the object which is equal to 4 meters. So our answer here is 40 joule. So why 40 joule? Now, since work is the product is equal to the product of force and displacement or distance, then we can just simply substitute the force, which is 10 Newton, and the displacement, which is 4 meters. So multiplying both, we get 40 joule. You might be asking, sir, what happened to the 2 kilogram? Isn't it not part of the solution? So I should say that the 2 kilogram there is only a distractor. It's not part of the formula that quantifies work. So work is equals to force times displacement. Next, number 6. What is the kinetic energy of a 2 kilogram object moving at 3 meters per second? Okay, in this item, we are asked to solve for the kinetic energy, or the key E. And the formula that quantifies kinetic energy is mass and velocity. So these are the factors that will affect the value of your kinetic energy: mass and the velocity. So your given is 2 kilogram and 3 meters per second. So our answer here is letter C, 9 joule. Why is it 9 joule? So you have here the equation for kinetic energy as key E is equal to 1/2 mv squared, or simply mv squared divided by 2. So using the formula, we substitute the given 1/2, then mass 2 kilogram, and the velocity, which is 3 meter per second. Take note that you still have to square the velocity before you multiply it with the mass. Therefore, 3 times itself is equal to 9. That's why there, 9 times 2 kilogram is equal to 18. 18 divided by 2, or 18 times 0.5, the answer is 9. And the unit is equal to joule. Yes, kinetic energy is having the same unit as work. Number 7. A machine does 500 joule of work in 25 seconds. Question: what is its power output. So in this item, we are asked to solve for power. And our scientific perspective of power is that it is work divided by time. Okay, and given are 500 joules of work and 25 seconds as time. So the answer here is 20 joule. So simply that is work divided by time, 500 joule divided by 25 seconds, and the answer is 20. And the unit is watts. Watts is equal with joule per second. Next, number 8. If an object is lifted to a height of 5 meters with a force of 100 Newton, what is the potential energy gained by the object? So here, our answer is 500 joule. So how do we get 500 joule? Now take note that potential energy or is or oh no, sorry, here is actually the question, I mean the right question with the right answer. The given are 10 kilogram object, 5 meters, which is the height, and acceleration due to gravity is constant in value, which is equal to 10. So potential energy is mgh, mass times acceleration due to gravity times the height. So since the mass is 10 kilogram, g is 10, and height is 5 meters, so that means 10 times 10 times 5. The answer is 500 joules. We just simply follow the equation. Potential energy is mgh. Number 9. If a 60 watts light bulb is left for 2 hours, how much energy is used? And we are given the conversion as 1 hour is equals to 3,600 seconds. Okay, so energy, just like work, okay, we can express work in terms of joule, same with energy. So our answer here is A, 432,000 joule. How did we come up with this answer? Now, we know that power is equals to energy divided by time. Therefore, if we're asked to solve for energy, we can solve for energy using power times time. And since the power is expressed in watts, in this case, that's 60 watts, and the time is for 2 hours, so we just simply multiply power by time. However, we cannot just directly multiply without converting the hour unit into seconds. Therefore, 2 hours must be converted first to seconds. So 2 hours times 3,600 seconds, since 1 hour is equal to this amount of seconds, so the answer is 7,200 seconds. So 60 watts times 7,200 seconds, the answer for energy is 432,000 joule. And finally, number 10, which of the following best describes power? And the answer here is, of course, power is always the rate of change of energy or the rate of doing work. It talks about how fast work is done because it is the rate of doing work or how much energy is transferred. Thank you so much for listening. Thank you so much for your time. And remember, keep going, keep growing. King Huan Learnings. Embrace learning.